Welcome, we'll start with projectile motions in 2 dimensions now. Let's quickly begin. Suppose I start with a very simple example. Here's a tower. Here it is. And here's the ground somewhere. And I take a ball and I throw this ball in the forward direction with some speed. So let's say I throw it with a speed of something like 20 meters per second, and I chuck it from a height. This height over here, let's call that as 20 meters. So it's going to start going in free fall, 2-dimensional free fall, and it's eventually going to hit the ground here with some velocity, some new velocity. And the question is, what is this horizontal distance traveled by the ball? So I want to calculate what this distance is, and I'll call it as r. And I want to know what r is. I also want to know what v is. And I want to calculate how much time it takes. So I want to calculate the time it takes to reach over here. And we're going to solve all this without using any new formulae. We're going to use our knowledge of one-dimensional motion and use the knowledge of vectors. Let's begin. To begin solving this, what we're going to do is we're going to talk about 2 perpendicular directions. So the 2 perpendicular directions are going to be one along the horizontal, which I'm going to mark over here. This is my horizontal, and one along the vertical, and the vertical will be downwards. Notice that these 2 directions which are perpendicular to each other, because they are perpendicular, the vectors in these directions don't affect each other. Something I've been trying to tell you over and over again, and because of that I can treat horizontal separately and vertical also separately. So let's look at these things from A to B. Let's look at it horizontally separately and vertically separately. Let's do that in a fresh paper. Alright, so along the horizontal, what do we have? Well, we have the initial velocity, which is 20 meters per second, and it's positive according to my direction. So we are doing the physics from A to B, and so initial velocity is at velocity as A, and that is 20 meters per second. What else do we know? Well, we don't know anything else. We know that the displacement is r. We know the time taken is t, but we don't know anything else. But what's about the acceleration? Think about it. When everything is going in the when things are falling, you see it's only being accelerated downwards. The entire gravitational acceleration comes only in the vertical direction. It has absolutely no effect, no component in the horizontal direction, which means good for us, because in the horizontal direction the ball is going in uniform motion. So something extremely important to remember is that regardless of where this ball is at any moment in time, for example when it's here or maybe when it's over here, we will always see that its horizontal velocity will remain the same, 20. That means when it's about to hit the ground, its horizontal velocity will be 20 itself. Of course, it's the vertical velocity that will keep changing. It will keep increasing. It's going to hit the ground with a very high vertical velocity. But the horizontal velocity remains the same. It's uniform motion. And therefore, we have only one equation. So this acceleration is 0. So we have only one equation in the horizontal. And that is S equals ut. Well, we don't know what S is. That's the displacement. And we don't know what the time is. Therefore, we can't really do anything in the horizontal. But I always like to start in the horizontal because it's very easy to do that because there is no acceleration. Who does not like uniform motion once you have understood kinematics? Okay, so we have no choice now but to go into vertical motion. So let's look at vertical. again from A to B. Well, what do we see in the vertical at A? Well, initial velocity was only along the horizontal, and this horizontal has no effect in this direction. Therefore, the initial vertical velocity is 0. What's the acceleration? Well, it's in free fall, so acceleration is downwards and it's positive because we have taken downwards positive. So acceleration is plus 10. Most of the time free fall, I'm going to consider it to be 10. And what else do we know? Well, we know the displacement. The displacement is also positive because the ball is moving from A to B, so it's positive 20. So displacement is plus 20. Oh, we found out 3 things. So we can find out the other 2. So I can go for S equals UT plus half A into T squared. So S is 20, that's equal to half times 10 times T squared. So 20 goes there to get 40, 0, 0 cancels, so T turns out to become plus or minus 2. But we're going to choose positive because we want to get an answer of time after the throw was done. Okay, so we have the time. What else can we calculate? Let's see. Oh, we have to calculate the final velocity in the vertical. So let's do that quickly. In the vertical, V equals U plus AT gives us V equal to U, which is 0, plus A into T. So V is 20 meters per second. But notice that's not your final answer. That's only in the vertical. So what we did now is so far only in the vertical. So this is the vertical direction. So we can go back over here and understand what's going to happen. Well, we calculated the vertical velocity is also going to be 20 meters per second when it's about to hit the ground. So what do you think is going to be the total velocity? Vectors. I hope you remember vectors, people. Well, we can use Pythagoras to do that. Now this is not a perfect parallelogram, but I did not do that initially. I mean, I did not know the answers initially. Anyways, here is 20 and here is 20. Therefore, our net speed, this is at point B, our net speed or net velocity is going to be V equal to 20 root 2. Pythagoras theorem, people. Pythagoras theorem. So we found out what the final velocity is. We found out the time taken is plus 2 seconds. And we also found out, what else? Oh, we did not find anything. We need to calculate the range. We need to calculate how much horizontal distance it travels. Well, that can be now done over here because we now know how much time it takes. So we can substitute that over here. The horizontal distance or the horizontal range is going to be U, which is 20 times 2. And that's going to be 40, right? Yeah, that's right. So S is going to be 40. So we found out everything. So we now have S or R, and that is 40. Also notice this angle which is going to hit the ground is going to be 45 degrees.